So next question is 22. Actually, it is related with the multi-range voltmeter theory. Same galvanometer can be used for 2-3 types of voltage ranges of different values. The resistance of the galvanometer is 50 ohm and it shows the full scale deflection for a current of 1 milliampere. To convert it into the voltmeter to measure 1 volt as well as 10 volt, refer the circuit diagram. The resistance R1 and R2 respectively. तर R1 चे 3 व्हॅल्यू 950 दिलेले आहेत आणि एक व्हॅल्यू फक्त 900 दिलेली. म्हणजे R1 वरून आपल्याला काहीतरी सांगता येईल. 2 स्टेप्स आपल्याला करायचे आहेत. So diagram is given like this. So this is the galvanometer. This is the first series resistance R1. It is for V1 is equal to 1 volt range. This is R1. So we have to decide R1. This is V2 is equal to 10 volt. Correct? This G is equal to 50 ohm. And the full scale deflection current ID is equal to 1 milliampere, that is equal to 10 raised to minus 3 ampere. R1 question mark, R2 question mark. This is R2. So we will solve the problem in 2 steps. First step, find series resistance RS1 for voltage range V1 is equal to 1 volt. So the circuit is like this. This is galvanometer. This is RS1 and this range is V1 is equal to 1 volt. So general formula is this: RS is equal to V upon ID minus G. So RS1 is equal to V1 upon ID minus G. So substitute here. So V1 is equal to 1 volt. ID is equal to 10 raised to minus 3 ampere minus 50. So that is equal to 1000 minus 50, and therefore RS1 is equal to 950 ohm. RS1 is equal to. So R1 is equal to RS1 is equal to 950 ohm. पहिला रेजिस्टन्स आपण फिक्स केला. तर चॉईसमध्ये 2 ठिकाणी आपल्याला दिलेला आहे. ॲक्च्युली तो 3 ठिकाणी सीमध्ये आपल्याला करेक्शन करायची. सीमधल्या व्हॅल्यू 950 ओम अँड 9000 ओम. आता सेकंड रेंज V2 साठी आपल्याला कॅल्क्युलेशन करायची. हा पार्ट महत्त्वाचा आहे. फाइंड स्टार आपण याच्यासाठी केलेला आहे. फाइंड सेरीज रेजिस्टन्स RS2 for voltage range V2 is equal to 10 volt. So diagram would be like this. This is galvanometer. This is R1. this is R2, and this is V2 is equal to 10 volt. So this total resistance combination has resistance RS2. So from figure, RS2 is equal to R1. We already know what to find R2. So this is equation A. So RS2 by using the equation of voltmeter. पुन्हा हेच इक्वेशन is करायचं. The new range V2 upon ID minus G. ID मध्ये बदल होणार नाही. So V2 is equal to 10 upon 10 raised to minus 3 minus 50. So 10 into 10 raised to 3 minus 50. So 10,000 minus 50. So that is equal to 9,950 ohm. RS2 is equal to 9,950 ohm. Put in 1, put in 8. So 9,950 is equal to R1 we have calculated 950 plus R2. And therefore R2 is equal to 9,000 ohm. 9,000 ohm. So the correct answer is R1 is equal to 950. This is 9,000 like this. So R1 is equal to 950 ohm. R2 is equal to 9,000 ohm. And therefore, the correct choice is C. तो C choice मध्ये करेक्शन करून घ्या तिथे. First resistance is 950, not 900, 950 ohm. Printing mistake is there. And second resistance is 900 ohm. Like this. So this second part is important. So in this way, by increasing the series resistance, we can increase the range. Now, sorry, this is R. So like this, we can add one more resistance R3 for the new range V3. So R1, R2, R3, R4 can be used in the similar manner for voltage ranges V1, V2, V3, V4. As the range increases, we require higher and higher value of series resistance. So R2 will be greater than R1, R3 will be greater than R2, etc. like this. So we can find each and every resistance required to convert the given galvanometer into the 2 or 3 different types of voltage ranges. Next, question number 23. When a metal conductor connected to the left gap of a meter bead is heated, the valence bond shifts towards right, shifts towards left, remains unchanged, remains at 0. तर सी आणि डी तर रॉंगच आहे. मग आता तो लेफ्टला जाईल का राईटला जाईल तेवढं फक्त आपल्याला ठरवायचं आहे ते. सो द arrangement is like this. This is a Western metal bridge. So this is LX, this is LR. This is R known resistance, this is X unknown resistance. The balancing condition is X upon R is equal to Lx upon Lr. This is equation 1, where R is a known and fixed resistance in right gap. X is a resistance of metal conductor in lead gap. X, or you can add here, which depends on temperature, its temperature. So we know the property of the conductor. Therefore, as metal conductor is heated, its temperature increases. Therefore, its resistance X also increases in lead gap. Therefore, by equation 1, as temperature increases, therefore X increases, therefore Lx increases, therefore null point will shift towards right. Null point will shift towards the right. इकडचा रेशन वाढला की ही लाईन वाढते म्हणजे हा नल पॉइंट इकडे जाईल. So the initial null point is N1, the new null point is the N2. So shift is like this. Shift of null point. Shift of null point towards left, and therefore the correct answer is A. Therefore, A is correct. A is correct. तर ब्रिजचे प्रॉब्लेम जनरली फिगर काढून सॉल्व करायचे म्हणजे लवकर जमतात. Actually, in this problem, there are no calculation, only way to give the direction of shift in null point. So this is the metal reactions. As temperature increases, its reactions will increase. X increases, therefore by this equation, numerator increases, therefore Lx will increase. Lx increases means this length increases. So null point shifts. Original null point was at N1, it will go to the N2. So it moves from N1 to N2 toward the right. So null point shifts toward the right. Next, question number 24. Potentiometer problem, so theoretical problem. For the measurement of potential difference, potentiometer is preferred in comparison to the voltmeter because A. Potentiometer is more sensitive than voltmeter. The resistance of the potentiometer is less than voltmeter. Potentiometer is cheaper than voltmeter, and potentiometer does not take current from the circuit. Correct is DA. The potentiometer की arrangement अपन अशी जातो. This is the potentiometer wire. AB. Here a cell is connected in series. This is the driver cell. This is top key. This is road cell. So this is E plus minus plug key and this is the road cut RH. This is called as a potentiometer. So battery will supply some current. So that current will flow in this direction. Let I the current supply. First wire, second wire, third wire, fourth wire, and then it will flow through this. So this is I. This is I. So current I is equal to EMF E upon R plus R. R is the resistance of the wire plus RH. This is the general thing. Now, in this circuit, we have to measure the EMF. This is galvanometer. This is D, null point. So this is unknown EMF E1. This is slider S. In null diffraction method, when slider S, or it is also called as a jockey, is at null point D, then galvanometer shows zero deflection, zero or null deflection, and therefore it is called as a null deflection method. Therefore, current ID is equal to 0. No current. No current through cell E1 in the measurement circuit. So, the correct answer is D. Therefore, measurement circuit does not take any current from main cell E in the potentiometer. So this is the correct answer. Therefore, D choice is correct. So measurement of EMF is possible only by potentiometer, not by voltmeter. Like this. So it is a theoretical reasoning. Next, 25. It is again related with theory of potentiometer. In a potentiometer, the null points are received at 7th wire. If now we have to change the null points at 9th wire, what should we do? Attach the resistance in series with the battery, increase the resistance in the main circuit, decrease the resistance in the main circuit, and decrease the applied EMF. So, the circuit arrangement we have already done. So, value of current is given like this. E is equal to EMF of the driver cell, R is a resistance of the wire, small r is a internal resistance of the cell, and R is equal to rheostat, resistance of the rheostat. Now, unknown EMF E1 is equal to R dash L1. This is equation 2. This is equation 1. Where R dash is equal to resistance per unit length of potentiometer wire. Potentiometer wire. R dash is equal to constant for a given wire. Given wire. Now, to get null point on 9th wire, instead of 7th wire, that is to increase the balancing length L1, to increase the balancing length L1. Equation 2 shows that current I should be decreased This is our requirement. In equation 1, E and E, R and R are constant. Therefore, by increasing RS equal to RH, by increasing RS is equal to RH in main circuit, we can decrease current and hence we can increase balancing length L1. Balancing length L1 so that null point shifts from 7th to 9th wire. So the correct answer is this cell. By increasing the RH in the main circuit, null point is shifted from 7th to 9th wire. And therefore, the correct choice is D. D is correct. ॲक्च्युली L1 जर आपल्याला वाढवायचं असेल तर ही EMF गिव्हन सेलची EMF आहे ती तर काही चेंज करू शकत नाही. म्हणजे आपल्याला करंट कमी करायला पाहिजे, R' कॉन्स्टंट आहे आणि करंट कमी करायचं म्हणजे एक तर E कमी करा, ड्रायव्हर सेलची EMF, तो चॉईसच दिलेला नाही आपल्याला. लक्षात. R म्हणजे वायरचा रेशन फिक्स आहे कारण R' कॉन्स्टंट आहे. स्मॉल r सेलचा इंटरनल. So E and R, these are constant for a given cell, given driver cell. So only the choice is this. By increasing the RH, it is connected in series with the cell, therefore it is also called as a RS, series resistance. So by increasing the series resistance, if it is say 90 ohm, then if we make it 200 ohm, then this RH increases, therefore current decreases, therefore this L1 will increase like this. Next, 26. Again it is a problem related with the piston meter pitch. A meter pitch is set up as shown in the figure to determine an unknown resistance X using the standard 10 ohm resistor. The galvanometer shows the null point when the tapping key is at 52 centimeter mark. The end corrections are 1 centimeter and 2 centimeter respectively at end A and B. Determine the value of X is dash dash dash. तर ह्या एंड करेक्शनचा मिनिंग महत्त्वाचा आहे म्हणून आपण हा प्रॉब्लेम ॲक्च्युली घेतोय. सो द अरेंजमेंट इज लाईक दिस. This is X, this is R equal to 10 ohm. This is 52 centimeter. This is null point D. This is 48 centimeter. So main point is this. LA is equal to 1 centimeter. LB is equal to 2 centimeter. This is point A. This is point B. So total Lx is this. Total Lr is this. Balancing condition is X upon R is equal to Lx upon Lr. Is equal to Lx is equal to La plus 52 centimeter. This is equal to LB plus 48 centimeter. So LA is equal to 1 centimeter, LB in correction in measurement of length, at end A. LB is equal to 2 centimeter is equal to in correction in the measurement of length at end B, and therefore x upon 10 is equal to 1 plus 52 divided by 2 plus 48, that is equal to 53 upon 50, 106 upon 100, and therefore x is equal to 10 upon 100 multiplied by this. So this is equal to 10.6 ohm. X is equal to 10.6 ohm. आपण नेहमीप्रमाणे काय केलं असतं, 52 upon 48 केलं असतं. तर 52 upon 48 केला तर आन्सर 10.69 येणार होतं. So the correct answer is B. B is correct. Now add one more point. Without considering end correction or neglecting end correction LA and LB, x upon R is equal to Lx upon Lr is equal to 52 upon 48 is equal to 13 upon 12. 13 upon 12, and therefore x is equal to 10 multiplied by 13 upon 12. So 130 upon 12. So that is equal to 10 point. Like this. आंसर मध्ये फरक पडला. बाय कन्सिडरिंग एंड करेक्शन and without considering end correction. Without considering end correction. दोघी आन्सरमधला फरक पण आपल्याला लक्षात यायला पाहिजे. 10.8 पण चॉईस आपल्याला दिलेला आहे. नेक्स्ट question number 27. The current passing through an ideal ammeter, याला अंडरलाइन करू नका, ideal ammeter in the circuit given below is 1.25 ampere, 1 ampere, 0.75, 0.5, like this. So actually for measurement of current, ammeter is always connected in series with the source. Here it is connected in parallel, but it is a ideal ammeter. So we know the property of the ideal ammeter ohmmeter. Ideal ammeter has 0 resistance like this. So the circuit arrangement is like this. So we will denote the resistances like this, plus minus. This is the event E equal to 4 volt. This is internal resistance R is equal to 1 ohm. This R1 is equal to 2 ohm. R3, R2 is equal to 2 ohm. R3 is equal to 2 ohm. R4 is equal to 4 ohm. And resistance of the meter Rm is equal to 0. This part is important. Ideal ammeter. So I will give the name to the points. This is point A, this is point B, this is point C, this is point D. Since an ideal ammeter has zero resistance, therefore Rn resistance of the ammeter resistance of an ideal ammeter is equal to 0. Since R4 parallel Rn between points C and D, therefore effective resistance RCD is equal to 0 ohm. Rm is equal to 0, therefore RCD is equal to 0. Therefore RT is equal to total resistance in the circuit is equal to small r plus R1 plus RAB plus RCD this is equation 1. Using 1, RT is equal to R plus R1 plus RAB, where RAB is equal to R2 parallel R3. So 1 upon RAB is equal to 1 upon R2 plus 1 upon R3, that is equal to 1 upon 2 plus 1 upon 2, that is equal to 2 upon 2, that is equal to 1. Therefore, RAB is equal to 1 ohm. Say this is equation 2. So putting 2. So total resistance RT is equal to 1 ohm plus 2 ohm plus 1 ohm, that is equal to 4. This is equation 3. Then current I flowing through the circuit is I is equal to EMF applied this upon total resistance. So 4 volt, EMF is given 4 volt upon 4 ohm, so that is equal to 1 ampere. So the current I is equal to 1 ampere. This is the correct answer. 1 ampere current is flowing through the circuit. जर आपण हा एमीटर काढून टाकला तर हा 4 ओम याच्या सिरीजमध्ये गेला असता, तेव्हा आन्सर वेगळा असतं ते. सो बी चॉईस इज करेक्ट. B is correct. Now one more point. And if ammeter is not connected, then RT is equal to R plus R1 plus RAB plus RCD, that is equal to 1 ohm plus 2 ohm plus 1 ohm plus 4 ohm, so that is equal to 8 ohm. RT is equal to 8 ohm, and therefore current I dash is equal to E upon RT, 4 volt upon 8 ohm, that is equal to 1/2, that is equal to 0.5 ampere. So I dash is equal to 0.5 ampere without ammeter. हा पण ज्यावेळेस आपल्याला दिलेला आहे डी मध्ये दिलेला आहे, तर डी का बरं रॉंग आहे त्याचं रिझन लक्ष द्यायला पाहिजे. म्हणजे हा जर 0 असेल तर सर्वच्या सर्व करंट इथून बायपास होतो, तर ते हा रेशन डायरेक्ट कट होऊन जातो सर्किटमधून. So remember this property of ideal ammeter. Ideal ammeter has zero resistance, so this resistance is 0. Therefore, current supplied will flow through the ammeter. No current will flow because this is zero resistance, and then it will flow like this. So direction of current will be like this. All the current will flow through the 0 ohm resistance. This resistance is directly disconnected from the circuit like this. So direction of flow of current and value of current are like this. Okay, we will stop here. We will see remaining problem next time.